Hi guys. So today we're looking at lesson 3-5, which is on converting quadratics. For your essential question, I want you to answer, how do you write an equation in vertex form from factored form? So how do you go from factored form to vertex form is what I'm looking for here. So just a couple of reminders before we get to our lesson. For vocab, remember that standard form is y equals ax squared plus bx plus c. Vertex form is y equals a times x minus h squared plus k, where h and k are your vertex. And lastly, we have factored form, which is y equals a times x plus f1, which is factor 1, times x plus f2, which is factor 2. So here is an equation that we have in standard form. And then I've also given you guys factored form. And I want to kind of take a look at the graph and see what we notice. So first of all, we know that our vertex is right here at 3, 4. Our axis of symmetry would be x equals 3. Also notice that our x-intercepts are at +1 and +5. So x-intercepts are at 1, 0, and 5, 0. So if you take a look at our factored form, you'll notice that the factors are the same numbers as our x-intercepts. They're just the opposite values. Okay. The other thing I want you to remember is that the axis of symmetry divides our parabola into 2 equal parts. And so the axis of symmetry is the center of our parabola. So the x-intercept to the right and the x-intercept to the left are the same distance from the axis of symmetry, which means that our vertex, the x value of our vertex, is halfway between those two values. So what we're going to see in our lesson today is that the x value of the vertex, again, is halfway between those. So to find the x value of the vertex from factored form, it's going to be the opposite of factor 1 plus the opposite of factor 2 divided by 2. So the opposite of -5 is 5. And this is the x value of the vertex. The opposite of -5 is 5 plus the opposite of -1, which is 1, divided by 2. And again, that gives you the x value of our vertex. So from there, we can plug that 3 into our factored form to find the y value of our vertex. And I'm going to show you that more in our guided practice. But again, what I want you to see here is that our factors have the same numbers as our x-intercepts, they're just opposites. And again, the axis of symmetry, the x value of the vertex, is halfway between them. So let's take a look at a couple of guided practice problems. So first, we have an equation written in factored form, and we're being asked to write it in standard form. So we're rewriting equations. We're going to write each equation in the indicated form. So from here, we need to go into standard form. Again, recall that standard form is y equals a x squared plus bx plus c. And so we need to multiply this out. We need to expand this out to get rid of all of our parentheses so that our equation is in standard form. So here, what we will do first, don't forget to add to your toolbox. First thing we're going to do is double distribute our binomials. So we're going to do x times x plus 9 minus 2 times x plus 9. So we double distribute the x, or distribute the x, excuse me. So that's x squared plus 9x. Then we distribute the -2, giving us -2x minus 18. Combine your like terms. That's going to be x squared plus 7x minus 18. But then we also have this a value out in front, which we need to distribute. So in standard form, we're going to have y equals 3x squared plus 21x minus 54. And that is converting factored form into standard form. So first we double distribute the binomials, and then from there we distribute the a value, or GCF is what it would be. All right, let's take a look at another one. This time we have an equation in standard form, and we're asked to rewrite it into factored form. So we're factoring this polynomial here, just like we've been doing in this unit, factoring this polynomial. Now notice that we have this leading coefficient, or this a value, that's negative. Anytime you have a negative a value, you need to factor out the negative as part of your GCF. So again, toolbox, when your a value is negative, you need to factor out the negative as part of your GCF. So if there's a GCF to take out, the negative needs to come out with it. If there is not another GCF to come out, you're just going to take out the negative. So we're going to divide out the negative, or factor out the negative, and that's going to basically change all of the signs here. So this is going to become a positive x squared, a negative 8x, and a negative 9. So from here, we now need to factor our polynomial, factor the trinomial here. So we multiply a times c, just looking inside the parentheses now. So 1 times negative 9 is negative 9. Our b value is negative 8. So factors of negative 9 that add up to negative 8, it's going to be 9 and 1. And remember, because our b value is negative, our larger number will be negative. So let's just check. Negative 9 times positive 1 is negative 9, and negative 9 plus 1 is negative 8. So we split our middle term to group. So we have x squared minus 9x plus 1x minus 9. We group. GCF of the first group is x. That leaves us with x minus 9. GCF of the second group is going to be a plus, and these only have 1 in common, which leaves us with x minus 9, giving us a factored form of x plus 1 times x minus 9. But again, remember, we factored that negative out at the very beginning, so that needs to go out front as our a value. And we want to write y equals because we had that y equals to start with. So this is our equation in factored form. Okay, so for our last GP, similar to what we saw in the explore problem, we are given an equation in factored form, and we are asked to write this in vertex form. Now, you could go through the process of rewriting this into standard form. So double distribute binomials and distribute the 2. And then once you have it in standard form, like we saw in previous units, we would find the vertex and then write in vertex form. But that's a whole lot of work when, again, like I showed you in the explore, we know that the vertex is halfway between our x-intercepts, and we know that the x-intercepts are the opposite values of our factors. So we know we have x-intercepts at negative 4, 0 and negative 2, 0. I'm sorry, positive 2, 0. So again, these are the opposite signs of our factors. So to find the vertex, to find the x value of the vertex, we use these opposite values. We add them together and we divide that by 2. So that's going to be a negative 4 plus a positive 2 divided by 2. So negative 4 plus 2 gives us a negative 2, divided by 2 gives us a negative 1. So the x value of the vertex is at negative 1. So from there, to find the y value, again, just like we did in standard form, we can take this x value and plug it in to our original equation. Now we're plugging this in for x because that's the x value. So y, which is what we're looking for, is equal to 2 times x, which is negative 1 plus 4, times negative 1 minus 2. So we're going to follow the order of operations here. We have to take care of what's inside the parentheses first. So negative 1 plus 4 is 3, and negative 1 minus 2 is negative 3. 2 times 3 is 6, and 6 times negative 3 is negative 18. So the y value of our vertex is negative 18. So if we're rewriting this in vertex form, our vertex, our h and k, are at negative 1 and negative 18. Now remember, vertex form is y equals a times x minus h squared plus k. So we plug in for h and k, but we also have to plug in for a. And remember that a value comes here. So we can take these values now and plug them into our vertex form. So y equals 2 times x minus h, so x minus a negative 1 will become x plus 1 squared plus k, so plus a negative 18 would just be minus 18. So again, we add the opposite of our factors together. So opposite of positive 4 is negative 4, opposite of negative 2 is positive 2. Divide that by 2 to find the x value of the vertex. Then we plug that back in to find the y value of our vertex. Then we can substitute in for h, k, and a for vertex form.